We'll continue our discussion on to transportation. So, how economically goods can be transported from one place to another place. It may be a minimization problem or maximization problem, and both of them can be a balanced problem or unbalanced problem. Balanced or unbalanced depends upon supply equal to demand. If supply is greater than or less than demand, it is an unbalanced problem. No need to worry about number of rows and columns like assignment here. Then three methods in which you can solve a problem. Least cost entry method, northwest corner rule method, Vogel's approximation method. First two are unscientific. At least to some extent we can take this least cost, but both we will never follow. We will follow only VAM. And even answer what you are getting here, we will call it as, it is a possible solution, but only it is a basic possible solution, not the final. Whether it is final or not, we need to check with Modi's optimality test. And in this test, we have three steps. Step 1, Cij. Step 2, Ui plus Vj for unallotted cell. Step 3, delta Ij. This delta Ij, in which all numbers, if it is non-negative, IBFS is optimal. Or here, all numbers are non-negative. If you have 0, IBFS is also optimal. If you feel negative number is there, then IBFS is not optimal. You need to improvise the solution by doing some iteration. Looping rules we need to follow. Start from the most negative cell, and for selection you need to choose delta Ij table, but lines shall be drawn in Cij table. So looping may be like a rectangle form or square or any shape in which looping may come. Finally, it should have equal number of plus and minus, starting place plus, next place minus, alternate place you need to assign, and always you need to stop at, except for the first starting place, all other place should be stopping place only, and you need to reach a place of start. This is looping, and wherever you have assigned minus quantities, you need to choose that, and you need to choose least amongst that for reshuffling. Then that plus places in which that least of these two quantities you need to add. In these places you need to add, here also you need to add. And after that, once again you need to check m plus n minus 1, because in first time before iteration there may not be a degeneracy, but here also 10, here also 10 would mean least of the two 10 only. So if you deduct both places, allocation gone means, in other cases here 10, here 8 would mean least will be 8. So that here allocation will be gone, here you will add 8. One place allocation gone, one place allocation will have. Both are 8 would mean both places allocation will be gone. Your allocation will reduce by 1. Definitely you will end up with degeneracy. Then how to tackle the degeneracy? Solve the problem in the normal manner, then somewhere you will not be able to proceed. In that row or column, whichever cell is least, in that place you need to assign E. E value is 0, epsilon, small value. And suppose if m plus n minus 1 equal to 8, allocation is 7 would mean you can insert only one E. If it is 6 would mean insert E1 and E2 and so on. That means least independent cell, next to least independent cell, based on which you can do. So how to find out multiple optimal solution also I think we have tried. That is, in delta Ij table, suppose if you are getting 0 as the value, and whatever negative for which steps you have done, same step if you try for 0, you will be getting the alternate solution. Because in examination or in revision test paper they are asking find out the optimal solution, and carefully they are using the word yes. That means they want you to find out the alternate solution also. If it is not asked, and one more thing, you see the mark also. If it is 4 mark question, don't try the alternative. If it is 6 mark, 8 marks would mean we can try the alternative. There is a logic or reason behind doing some extra work. And I think questions which you have completed are 1, 2, 4, 5 and 6. We have finished completely. Question number 3, first two, that is all the 3 methods we have done. Optimality test is pending. That we will try it today. And before that, Okay, we'll try it today. That question number 3. And you need to tell IBFS under WAM. First, it is basically an unbalanced problem, so we could have balanced it 3, 4, 5. And you need to be cool. You should have perseverance. You should not get tension. Clear? So sometimes in movies they will tell this movie is not for heart patients. So please be cool in doing this problem. And first row where we made allocation 3, 15. Then second row 3, 10, 12, 2, 8, 7, 5. Then third row 0, 20. Fourth row 5, 15, 3, 25. That's all. Check it up. First one 15, 20 plus 8, 25, 20, 40. Column wise 12, 8, 15, 20, 35, 25, 20. 4. Now, number of allocations 1, 2, 3, 4, 5, 6, 7. M plus n minus 1, 1, 2, 3, 4. 4 rows, 5 columns minus 1. 9 minus 1. 1, 2, 3, 4, 5, 6, 7, 8. It is not equal. Check it up. Do you have only 7 in your solution? Okay. We need to insert E. Now where to insert E we may not be knowing. So step 1 Cij, like any other problem you proceed normally. Ui Vj. Now please tell which row or column from which we need to start. Either second row or third column. Okay, second row from which if you start 0, then 3, 2, 7. Then using the 7 here you can update. This is not 4, this is minus 4. 7 minus 4. Then using the 7 you can update here. Minus 2. Then using this minus 2 you can update here. 5. Then check is it possible to update here or here. Is it possible to update here or there? In that row or column is it possible to update I am asking. No. So that is the independence row or column in which least cell being 0. But here 1, 2, 3 zeros we have. Any one you can choose arbitrarily. Which one we will choose? Column? Row you tell. Which row? 0. First row 0. Enjoy. Insert E. So minus 4 plus what? Here you will be getting 4. And 4 minus 4 will be 0. Step 1 over. Step 2. Ui plus Vj for unallotted cell. One, two, three, four. minus 4 plus 3, minus 1, minus 4 plus 2, minus 2, 1, 0 plus 5, 5, 0 plus 4, 4, minus 4 plus 3, minus 1, minus 4 plus 2, minus 2, 3, 1, 1, 0, 2. Step 3, delta ij You don't use color pen, just for highlighting I am doing that. For decoration, not even negative marks will be given. I am not telling about positive mark, not even negative mark will be given for decoration. Only the way in which you answer for which marks will be given. Now, 7 minus of minus 1, 8. 4 minus of minus 2, 6. 4 minus 1, 3. 5 minus 5, 0. 0 minus 4, problem started. Minus 4. 4 minus of minus 1, 5. 4 minus of minus 2, 6. 3 minus 3, 0. 7 minus 1, 6. 9 minus 1, 8. 7 minus 0, 7. Minus 2. So, presence of 0 does not implies it is a multiple optimal solution. It is a still not optimal solution only IBFS because of presence of negative. Now, of the two, which one is? People will tell, I like party A. Another person will tell, no, I like party B, political party. I have voted for these people. Whether party B is good, whether they are coming from heaven, then compared to party A, in Tamil people will tell, but it is not something greatest joke, whether tea is better or coffee is better. People will tell tea is better. Because in tea, only one E is there. Coffee, two E's are there. If you know Tamil, you can enjoy it. E means fly in Tamil. So, which party, political party is better? I have voted for political party number B. So, whether they are coming from heaven. So, when compared to A, they may be better. Like that, which one is worst in negative, we need to choose. Minus 4. And last class for basic discussion, separately one more table we have drawn, then we have done the work. Now, we are not going to do that. Here itself, we are going to do looping. And first write the conclusion. Since delta ij table contains negative value, IBFS is not optimal. Then here we will draw looping lines. Since delta ij table contains negative value, IBFS is not optimal. Clear? Now, can you please tell, if you start from here, how to draw looping lines? 0 to, can we go down? So, we can go up, then left, then down, and right. Numbers should be visible. So, starting place plus, minus, plus, minus. And the minus we have it in phi and E. So far, whatever problem we have tried, in minus places some number will be there. Here we are getting E. So, phi or E, which one is smallest would be E is smallest. First iteration, reshuffled matrix. You don't do it in right hand side. I want to compare parallelly this matrix and see. We don't have a notebook to see left hand side, right hand side. You don't do it immediately. Okay. Now reshuffle matrix And this itself will take it as step number 1 for next stage. So leave space for writing step number 1, etc. 1, 2, 3, 4, 2, 3. 7, 4, 3, 4, 0. 3, 2, 7, 5, 0. 4, 4, 3, 7, 0. 9, 7, 5, 3, 0. Now 15 plus E will be 15 only. E minus E allocation will be gone here. Here you will be getting E. In this place you will be having 5. Other things will not change. One, two, three, 4, 5, 6, 7, 8. Sorry? Here? Should be coming here. Okay. Now allocation 8, m plus n minus 1, 4 plus 5 minus 1, 8, both are equal, no degeneracy. Step 1, C.I.J, U.I.V.J, where from which we need to start second row. So 0 plus 3, 0 plus 2, 7, 0. Then 0 plus 0, 0 here. Then 7 plus what? 5 minus 2. And minus 2 plus 5 will give you 3. 7 minus 4 will give you 3. Step 2. Step 2. Minus 4 plus 3 minus 1 minus 2 1 minus 4 5 3 2 7 5 1 0 minus 2. Step 3. Seven minus of minus 1, 8, 4, 6, 4 minus 3, 1, 4, 0, 1, 2, minus 4, 2, 8, 7, 2. Below that you write, since delta ij table contains negative value, first iteration reshuffled matrix is not optimal. Since delta ij table contains negative value, First iteration reshuffled matrix is not optimal. Completed. Now coming to Cij table, -4, here it is 3. How can we draw line? Left I cannot stop somewhere. I cannot go left. Down, right also I cannot go after this. Up, right, down, left, over. Plus, minus, and minus places 5, 20. Lowest being 5. Second iteration. See, solving problem will not be difficult or great. The drawing table will irritate us. 7, 4, 3, 4, 0, 3, 2, 7, 5, 0, 4, 4, 3, 7, 0, 9, 7, 5, 3, 0. 15 will be 15, 12 will be 12, 8 will be 8. Now 5 minus 5, allocation gone. E is 0. So 0 plus 5 will be 5 here. Here no allocation was there. Now it will become 5. Here 20 minus 5, 15. 15 and 25. Can check it up. The 12, 8, 20, 35, 25, 20. 15, 20, 25, 20 and 40. Step 1, Cij. Before that, allocation 1, 2, 3, 4, 5, 6, 7, 8. M plus n minus 1 also 8. So no problem. Ui, Vj, second row. Okay, second row 0, 3, 2, 0. 0 plus 0, 0. 0 plus 3, 3. 3 plus 3 plus 2, 5. 2 and 1 will give 3. And here 0. 0 plus 3, 3. Two, 3, 4, 5, 6, 7, 8. Zero plus 3, 3. 0 plus 2, 2. 1, 0, 3, 1, 3, 2, 1, 5, 4, 2. Seven minus 3, 4, 2, 3, 0, 4, 4, 1, 2, 6, 4, 3, so don't lose heart. That is the solution for this problem. Don't worry.